Okay, our last video on these homework questions for section 5.2 is number 52. Okay, 52 was dealing completely with the calorimetry questions and taking some heat capacities and specific heat and applying that. Okay, so when you're dealing with calorimetry, you have to understand the difference between heat capacity and heat capacity is abbreviated with a C. Specific heat is abbreviated with an S. Okay, heat capacity is how much temperature it takes to increase it by 1 degree, to raise whatever by 1 degree. Specific heat is how much heat it takes to raise 1 gram of the substance by 1 degree. Okay, so our S's and our C's there. Okay, so if we understand that, and we also learned in the last problem that the units for specific heat are joules, for heat capacity are joules per degree Celsius or joules per degree Kelvin. Okay, now specific heat has a little bit more to it because we're throwing grams in there. So we can put kelvins in here, but I'm just going to write 1 joules times degrees Celsius or kelvins, whatever you have. But that's always going to be a change of temperature, and change in temperature is always final minus the initial. Okay, so for 52, okay, on 52 then, 52 tells us that we start with a specific heat of 2.42 joules per grams times kelvins. And it wants to know what our joules is. Okay, our formula that we're going to use here is S equals Q times G, Q divided by G times the change of temperature. Okay, keep in mind though that we are actually looking for our joules, so we're going to look for Q, or the heat that is given off. So if we rearrange this equation, it is actually, hold on, okay, it is actually S times the grams times our change of temperature equals Q. And as we read 52 now, we know our formula. Our S is 2.42 times our grams, which is 62, times the change in temperature. If we go final minus the initial, we find out that our change of temperature is 25.6. Okay, you add all that together, bada bing, bada boom, you should get 3.84 times 10 to the third joules. Okay. We will use heat capacity when we're dealing more with calorimetry. Okay, so we are back on deck now. Let me scoot that up a little bit and just write a few more things here. Okay, so that is a calorimetry question. So just some formulas that we probably need to become familiar with. Know that, hold on, kinetic energy equals half the mass times the V squared. That mass, if it's looking for joules, your mass needs to be in kilograms, and if it's looking for kilojoules, leave your mass in grams. It's kind of some weird work with the units there, but that's that. Okay, know your specific heat formula, that S equals Q over G times the delta T. Your internal energy equals energy added together. Okay, also understand how the system relates to the surroundings and how that affects the exo and the endo. If the system loses, it'll be a negative delta H and it would be exo. If the system gains, it's a positive delta H and it would be endo, and it would be gaining from the surroundings. So you have to watch those in those questions. Okay, so just a few other things to those formulas to be familiar with. Also, just always make sure you know what your sign is for the work or heat being done, whether it's a positive being added to the system or a negative it's leaving the system. Watch for those things. Okay, after you get done with these videos, you should still have roughly about an hour of class left. So here is you some more problems to do. Kind of a lot reviewing. You're in the same sections of your homework problem. A lot reviewing some similarities, some similar formulas will be used. But we're going to go, am I right? Section 5.3, sorry, assignment 5.3, starting on page 207. It's going to be numbers 29. 29 deals with state functions and just explaining that. Okay, question number 34 deals with writing the balanced chemical equation from the information given, and then draw a diagram for the reaction, enthalpy diagram. So you may have to go back in the chapter and look at an enthalpy diagram, basically just showing how the heat is lost or gained. Okay, question 35 is another enthalpy question. It gives you a reaction, and you have to discuss if you have a coefficient of 2, does that give you a higher enthalpy or a Cl2 molecule? So you really have to understand what, like in the picket fences and things, what you're doing there. Okay, question 36 is a tricky one. I like it, but you have to refer back to the video, like the heat of fusion, the heat of vaporization. How's that going to affect enthalpy? Does it take energy to change from a solid to a liquid, or does it remove energy? So you don't have to think of how you're going through your different phases of matter there. And that's 36. Then you will have 49 to do. Okay, 49 is a calorimetry question. It's basically using the specific heat formula that we just wrote down and talked about in the last couple questions. Okay. Number 56, I like number 56. It's tricky. Make sure you are aware of all the information you have, and you refer back to the beginning of the problem a lot for the problems that you'll need. But again, the formula you're going to use for that one is in the calorimetry section, and you're going to be using the the formula you will want to use on 56 is basically the heat of the reaction equals the negative heat capacity of the calorimeter times the change in temperature. That formula is found on page 186. Okay, that kind of goes through and it gives you an example. You can follow along there. Remember, C is heat capacity, S is specific heat. And the last question, this comes from one of the videos with the target equations, is number 63. So remember, if you multiply the equation, you have to multiply the enthalpy change. Or if you flip it, you reverse the sign. Okay, so these two right here will probably require you to think, but I know that you guys are smart enough you can do it. That's why I give you these challenging things, and good luck with those. If you get done with all these problems and you work well, the sub will be happy, I will be happy, and you won't have homework. But watch for some more videos to come up from chapter 19, I believe. Yep, chapter 19. We have some topics in there to cover. Okay. Peace out.